Welcome to Geometry PLP Essential Standard 3, Learning Target 7B, Parallel Lines and Transversals. Okay, so last class we talked about transversals and lines. A transversal is a line that intersects two other lines, or at least two other lines. So what we're going to talk about today is when you have parallel lines cut by a transversal. So notice the red arrows here. The red arrows on those two lines mean that these two lines are parallel. And then we have our transversal here that intersects those two lines to create the parallel lines with the transversal. Okay, so we're going to talk about a few postulates today. We're going to talk about some theorems and how they're going to affect parallel lines and transversals. So the corresponding angles postulate says if two parallel lines are cut by a transversal, then their pairs of corresponding angles are congruent. We talked about corresponding angles in the previous lesson. Corresponding angles, if you remember, the way that I like to remember them is corresponding angles are going to be in corresponding locations or in the same location with respect to the line and the transversal. So notice we have one of the parallel lines, the transversal. So notice angle 1 is top left, angle 3 is top left with this relationship. And so that means that angle 1 and angle 3 would be in corresponding locations, which means that they would be congruent. 5 and 7 would be corresponding, 6 and 8, 2 and 4. Notice they are in the same locations with respect to the transversal and the parallel line that they are associated with. We have corresponding angles postulate as well. This is the converse, so this is kind of where you flip the hypothesis and conclusion. This says if the corresponding angles are congruent, then the two lines would be parallel. So this says if the lines are if the angles are congruent, then M and N, the two lines, would be parallel. So it's just the converse of the previous statement. So let's look at how we could actually use this. It says find angle QRS. So angle QRS would be this angle right here, QRS. Well, what do we know? We know that we have parallel lines because the red arrows here, and 118 would be a corresponding angle with this X right here. So this right here would be 118 degrees. So this here is 118, this here is 118. And what do we know about this 118 degree angle and this QRS angle that we're referencing right here? Well, QRS and 118 would make a linear pair. So we know that 180 minus 118 would make up the angle QRS. Well, if we subtract that, that would be 62 degrees is angle QRS. This one says use corresponding angles postulate. So A says find each angle measure, the measure of angle ECF. So we ECF. So A is looking for this one right here. We're looking for angle A or this angle right here, ECF. Well, we know that this angle ECF, this blue one right here, is going to be a corresponding angle with angle 70, and since we have parallel lines cut by a transversal, this angle would be 70 degrees. Now it says to find DCE. DCE would be this angle right here in red. Well, what do we know about the angle in blue and the angle in red? They are going to make a straight line, which is called a linear pair. And we know linear pairs add up to 180. So that means that this would have to be 110 because this angle of 70 degrees and this angle of 110 degrees would add up to be 180 degrees. And so that's where we get the 110 degrees. It says find each angle measurement. So we have EDG. So we need to locate EDG. So the first angle we're looking for is angle EDG, which is that red angle right there. We have parallel lines cut by transversals. Notice the red arrows. We know that this angle up here is 75 degrees. which makes this angle right here 75 degrees because those are vertical angles from previous lessons. If that is a 75-degree angle, this angle right here, up top here, and this angle right here, the one that we need to find are going to be corresponding angles. So we know that this angle right here would be 75 degrees. The next one is BDG. So BDG is this angle X right here, or this green angle that I just labeled. BDG and EDG form a straight line. So we know that this angle 75 would have to be added to some number to get 180, and that would be 105 degrees. So this angle right here would be 105 degrees. So now we need to see, is it possible to prove lines P and Q are parallel? Well, in order to prove lines are parallel, we have to state that corresponding angles are congruent. So if we look at this, we're trying to say P and Q are parallel. They look parallel, but do not assume that they are parallel just because they look parallel. Okay? What you have to do to prove it is say that the corresponding angle with 102 would have to be 102 as well. The corresponding angle would be this big angle right here that I just highlighted and drew in green. Well, how do we figure out what that angle is? We take the two angles that create it and we add them together. 90 plus 22 would be 112 degrees. Are those two angles congruent? No, they are not. So since they are not, we would say no lines P and Q are not parallel. And then you can do the double lines, which means parallel. So no, the lines P and Q are not parallel because corresponding angles are not congruent. So we have some other ones. We have parallel lines and angle pairs. Remember, we have alternate interior angles, we have alternate exterior angles, and we have same side interior angles. Alternate interior angles are congruent. That's what this says. Alternate exterior angles are congruent, and same side interior angles are supplementary. Remember, supplementary means they add up to 180, and that's what this conclusion statement says over here. So let's look at how to use those as well. We have a couple more. The converse basically is the converse. It says if the angles are congruent, then the lines would be parallel. If the angles are congruent, lines would be parallel. And if the last one, if they are supplementary, then the lines are parallel. It's just the opposite or the flip of the previous statements. So let's use those. It says find angle ABD. So here's angle ABD. So it's this angle right here. That's the angle that we're trying to figure out. We don't know any specific angles. It just tells us an algebraic expression for angles. So what do we know about this angle that I just highlighted in green and this angle right here that I'm going to highlight in red? Well, we know that those are going to be considered alternate interior angles. Because we have parallel lines, we know that alternate interior angles are congruent, which means, since they are congruent, that means they are the same size, same shape, and by definition of congruence, we can say that they are going to be equal numerical values. So that means you can say that 2x plus 10 is going to be equal to 3x minus 15. Because these are alternate interior angles, they're going to be the same numerical value. Now we have an algebraic equation. We have to solve for x. Subtract 2x from both sides so that we can get a positive x variable. 3x minus 2x is x. The 15, negative 15 drops down, and then the 10 comes down. We then add 15 to both sides to get x by itself, so I'm going to get x equals 25. Now, the question does not ask me to find x. The question says, what is the angle ABD? So we're not finished. So what we have to do is we have to figure out angle ABD. And what do we know about angle ABD? ABD is equal to 2x plus 10. So now what we do is we replace x with what x is equivalent to, which is 25. And you would get 50 plus 10. So that would become 60 degrees. So this is the angle A, B, D. This is what the question is asking us to figure out. Okay. Next question says, is it possible to prove lines P and Q are parallel? If so, state the postulate or theorem you would use. Well, in order to state if things are parallel, we need to prove either angles are supplementary or angles are congruent. Well, we have 102 right here, and we have some information about this angle over here. Well, alternate interior angles would be this big angle that is, I just highlighted in green. Well, what do we know about those two angles that make up that big angle? They're 52 and 50. If you add 52 and 50 together, that big angle would be 102 degrees. So are those congruent? Yes, they are congruent, or not congruent, parallel. So P is parallel to Q because alternate interior angles are congruent. So that would be the converse of the alternate interior angle congruence theorem. It says solve for x. Notice we don't need to find the angle measurement, we just need to find the value of x. Well, what do we know about the value of x? Or what do we know about these two angles? This angle here in green and this angle here in red. Those two would be considered same side interior angles. Same side interior angles are supplementary, which means that 2x plus 43 plus 2x minus 3 have to add together to be 180 degrees because they are same side interior angles. So now what we do is we simplify or combine like terms. 2x plus 2x is 4x. 43 minus 3 is plus 40 equals 180. Solve for x, subtract 40 from both sides. So we get 4x equals 140. Divide by 4. Divide by 4. And you would get x equals, what is that, 20. So we can use the calculator if you're not sure. So use the calculator. We would do 140 divided by 4. And that equals 35. So x would equal 35. Now we don't put a degree symbol on that because x is not an angle measurement. X is just the value of x that would make that angle measurement. So do not put the degree symbol on that. Okay, it says, is it possible to prove lines P and Q are parallel? If so, state the postulate or theorem you would use to prove that. So we have this big angle right here, and we know something about this angle down here. This green one and this red one would be considered same side interior angles. We know that those would have to be supplementary. So what do? We take 54 and 74 and we add them together, which would make 78. And then we see if they are supplementary. Was 102 plus 78, is that going to equal 180? And yes, it does. So then P is parallel to Q because same side, interior angles are congruent. And I'm going to use the congruent symbol. Are congruent. And that would be the converse of the same side interior angles theorem. It says find W, X, Y, and Z in the diagram. So notice we have two parallel lines with the red arrows. Okay, we know some angle measurements. 25, we have 85, but we need to find W, Y, X, and Z. So what we can do is, what I usually do is I just set up my variables and I'm trying to find W, X, Y, and Z. And I don't necessarily go alphabetical. I don't necessarily start with the left one, the right, and then go that way. I just start filling out, trying to figure out what information I can come up with based off of this right here. Well, notice that X, 25, and 85 form this straight line right here. Well, since 85, 25, and X form a straight line, that means they have to add up to 180. That means that 25 plus 85 plus x has to equal 180 because those form a straight line. They form a 180-degree angle. So 25 and 85 would be, what is that, 110 plus x equals 180. That means when I subtract 110 to solve for x, I would get x equals 70 degrees. So that means that x is 70 degrees. So I can fill that in down here. And so what I also like to do is I'll fill that in right there. Okay? Now I can start figuring out some other information. Well, x and y are going to be considered alternate interior angles because we have a parallel lines cut by a transversal. So y is also going to be a 70-degree angle because they're alternate interior angles, and because they're parallel lines, alternate interior angles are congruent. Well, what do we know about y and w? Y and w have to be supplementary, or 180 degrees, because they're a linear pair. That means that w would be 110 degrees. So if we have that, then we know that's 110. Now we need to figure out what z is. Okay? So another thing you can do is go in and start filling these in. That's 70, that's 110. Okay? So we have parallel lines, we have transversals, so what we would want to do is we'd want to figure out what some information is. We can also say that this here is 70 degrees, okay? Because this x angle here and this 70-degree angle here would be considered vertical angles from a few units back. That would make this angle here 25. That would make this angle here 85, okay? Because of vertical angles as well. Well, what do we also know? We know we need to find z, and we have parallel lines cut by transversals. We could say, know that this would have to be a 25-degree angle because parallel lines cut by a transversal. Z would have to equal 25 degrees because of this parallel line cut by this transversal. So 25 and z would be alternate interior angles. And that is all we have for this lesson for parallel lines and transversals. Schedule your teacher talk. Thank you.